Today we're going to have a demo for the actuators. Like we said, the most common actuators are motors. I have a bunch of motor demo today. They are all electronic motor and DC motors. So the first one I'm going to talk about will be, let's see this one. So this is a typical DC motor. So it has two connections. So if you connect the positive to the red, it will rotate one direction. If you reverse the battery, it will reverse the direction. So this is a permanent magnet. So there is a permanent magnet, and this motor, all the motors, this motor came free from an old printer. So if you have an old printer, don't throw it away. Instead, open it up. They have 5 or 6 of those. Also, this is a DC motor. This is a stepper motor. So the DC motor will be convert electrical power to mechanical. Every motor can also be acted as a generator. So this DC motor can also be used as a generator. All you need is having mechanical power on this side. And for example, if I see the demo, first demo. So if I rotate my the LED will turn down. Now it's not very obvious, but so that LED is turned on because I'm doing this. I'm converting my the breakfast I just ate, right? I ate some breakfast, and that energy is absorbed by me and then goes to my muscles, and I will doing this. So I will burn some calories. That calorie I burned will be converted to electrical power. So this is our first one. The second one we'll do is this. This is also a DC motor. So inside this motor is a small DC motor. So what's the difference? The difference is this motor is called a servo. So that is a motor. This motor has 2 connections. So the battery is battery is connected to it. But this motor called a servo because there's a mechanical and electrical components inside. So if you open it up, you will see mechanical gearboxes made of plastic. You will also see electrical circuits. So this type of servo, usually this type of a motor called a servo because the electric drives are built inside. So inside there's an electrical drive circuit. And when the computer wants to control this motor, computer has a very easy job to control because most of the hard work is done inside. So this is called a servo. This servo is called the standard servo. The standard servo only rotate 180 degree in one direction, and then start, and then reverse another 180 degree. So this servo do not have RPM. It's only angles. How do we control this servo? Let me share a document. This document will tell us how computer can talk or control a servo. No. So I'm going to, unfortunately, this Zoom, not Zoom, my computer do not have Word, Microsoft Word. So I cannot share this Microsoft Word document.
Well, wait, can't you open it on like Google Docs or something?
Yes, that's what I'm doing. Great suggestion. Yes. So right now I'm sharing this with suggested by Craig. So now I can share. Let me share with you. Share. All right. All right. This is a standard servo, and it is controlled by a binary electrical pulse, which is 200 milliseconds apart. So if it's 1.5 millisecond wide, the width of that pulse is 1.5 milli. This servo will be 0 degree. If it's 1.3 milli, it will be negative 180 degree. If it's 1.7 milli, it's positive 180 degree. So what about in the middle? If it's what is the middle? 1.6, for example. 1.6 will be 90 degree angle. So by controlling the pulse width, we can control the standard servo at any angle. This is very common in, for example, remote controlled airplane, remote controlled vehicle, robots, very common. Yeah, because we want to control certain action. So that's a perfect application for that. I built a solar tracker with my son. That's the solar tracker. So this is a solar tracker I built. It's two axle. So it will track solar. It will track solar, so the solar panel will have a better power output, right? It's an easy project with this standard servo. All you need is to control the X two angles. The difficult part, one of our electronic graduates, I still remember his face so vividly. That's almost like 10 years ago. He built a solar tracker. The difference between mine is his, and he built an excellent mechanical component. He has a real big solar panel, not like the one I have, like a little toy. With motors, he salvaged from a power window. So those are big, powerful motors used on power window on the automobile. So these are perfect example. So his solar tracker actually is a real stuff. Can definitely put in your backyard and track in the sun. So so this is called a standard servo. But today I'm going to do another servo called the continuous rotation servo. So standard servo only rotate the positive, negative 180 degrees. That is good for some applications, but there is no RPM, so you cannot drive a vehicle. So what I'm going to do today is we have two continuous rotation servo. So the continuous rotation servo, unlike standard servo, the pulse width controlled RPM. So if it's 1.5 milli, there's no RPM. So the motor will just zero, not moving. If it's 1.3 milli, it will move backward, full speed backward. If it's 1.7 milli, it will move forward, full speed. So let me give you guys a demo. I will basically, this is my 2 servo motors, standard, not standard, continuous rotation. I have a little chassis and I have 2 wheels. So now this is my computer. And my computer, I will program my computer like this. And with my program, I will control the 2 wheels. So it will go forward, backward, or left, turn right, or rotation. Whatever I want to do, it will do it. So let me share the, let me first open it, then share it. Open the program, and then let me share the program with you. And then we download and see what the program does. So the code is called all right, now I got it share. Now this is the code to download to my computer. Once the code is downloaded to my computer, it will control the 2 wheels. Actually, I already downloaded. So as soon as I connect the battery, this vehicle will start moving because the program is already been downloaded during the weekend when I was preparing for this lab. Already downloaded to this chip right there. So as soon as I powered it up, the computer will start it control those 2 wheels. How do you control it? Just by sending out the pause signals, pin number 14 and pin number 15. I highlighted the program I share right here. So pin number, everybody see the program, right? Just get it.
Yes. Yeah, we see the program.
Okay, perfect. So that 2 line is the 2 lines send out certain pulse out to pin number 15 and pin number 14. And then I will pause 20 milliseconds. Then I will repeat. So basically, I will experiment driving 2 wheels, forward, backward, different combination of forward, backward to see how my vehicle will respond. So instead of doing the program now, I already programmed it, so I just disconnect it. Because as soon as I power this thing, this vehicle will start moving. So it will move. So right now it's moving forward. Now it's rotation. Now it's moving backwards. Now it's moving backwards. I don't have a big enough window, but you got an idea. Now it's rotation backwards. Clockwise and counterclockwise rotation. So basically, I control this robot whatever way I want it to control. This thing is like a 0-turn mower, right? Because it has 2 transmissions. That's exactly how the 0-turn mower is built. They have 2 transmissions, two drive 2 wheels, and the front wheel is just a little dummy wheel right here. So that's a 0-turn. So it can rotate like this. So that's another demo. This computer can also connect to infrared, so it can be controlled by a remote control like this. That's one of the projects we did. Remote controlled robot vehicle. And the next motor I'm going to talk about is this motor. This motor is everywhere. It's a dirt cheap. It's inexpensive. You can buy those for like a dollar. So what exactly is this motor? This motor is called brushless DC motor. So if you remember on Monday, we talked about the brushless DC motor. One thing I commented about brushless DC motor is it's expensive. But this brushless DC motor is designed so simple and built made in China. Okay, so it's a dollar. So this is what's inside the brushless DC motor. So there's no brush. So it's a DC motor. So that's the two power. The red and the black is power. How about the yellow? The yellow is RPM. So this brushless DC motor has sensors inside, measure RPM. So there's no brush inside. So if you look at this, there is no brush. So, and it is so simple. There is a little bit electric circuits right underneath this plastic cover. So if you pry open, if you take this out in the back, there are some electrical circuits. That's all there is. And also, if you look closer, right here, there's a black sensor. This black sensor is a magnetic sensor. So this brushless DC motor has a magnetic sensor right here. And it has a full coil. This full coil is energized by the circuit. So what happens is the DC power over here will be changed to AC power. The AC power will take turns to drive those full coil. And it just so happens it will drive this full coil based on the feedback from the sensor. So you see, there is a sensor right there. And the sensor will tell how the coil will be driven. Then there's another magnet. That's the rotor. The rotating part is just a solid, not solid, this time actually two pieces of magnets. So it's a solid construction. So that is why brushless DC motor should last forever, right? The only thing you need to maintain is this little, I'm not sure you can see it. There is a little bearing right here. Yeah, right there. As long as you keep that bearing happy, this motor will last forever. As long as you can. The electronics component is so simple, it also lasts forever. So this motor is generally used on computers, for example, for cooling. So if you have a computer, you turn it on 24 hours a day for 10 years. That means almost 10,000 hours operation. So this motor lasts longer than 10,000 hours. So you seldom see those motor fails. The only reason those motor fails is you do not do maintenance. There's a lot of dust and dirt get accumulated inside, and your motor gets stuck. That's the only way this motor fails. So that is a brushless DC motor. The sensor will tell the coil when to change polarity. So the coil will always driven this rotor forward or backward. So this is a simplest brushless DC motor. The expensive brushless DC motor is identical The only difference is bigger. Instead of simple circuits, they have computers. Once you have computers, you can control the RPM, torque, forward and backward. This one only forward, only forward. So it will draw air in one direction. So let me give you a, actually everybody has one. If you have an old computer or some kind of old electronics, chances are you can salvage one of those, right? So what I'm going to do is give you a demo. Yeah, kind of a demo. That's the battery. So I will turn this thing on. Have to be positive and negative. So this brushless DC motor will rotate. There is no control of RPM. This motor, brushless. If we have a computer, we can control the RPM very accurately. But now it's just run as fast as it could. Yeah, it's just run full speed. The only way we can kind of control the RPM is change the voltage. Change the voltage. So if I have a smaller voltage, this is a 3. 3. Yeah, it's almost don't want to start. This is supposed to be driven by 12 watts. Maybe my battery is dead. I didn't check the battery. Anyway, this motor, the RPM is not controllable generally. You can control a little bit by having different voltages. At 12, it will run faster. At 9, it will run slower. If you have a 5, it will run even slower. Let me put 5. So that's another motor called brushless DC motor. The more expensive ones is identical. The only thing you need to change is the electronics part. So you replace that with a computer. So that's what it is. And today, some of the brushless DC motor do not even have this sensor. Do not have the sensor. This is called the sensorless brushless DC motor. Why sensorless? Because they want to save a couple of cents, right? They want to save some money. Also, sensorless means less likely to have a problem. So the simpler the design, the better. Unfortunately, in order to be sensorless, you have to have a real complicated computer to behind it. So yeah, you make a compromise. So if you want to be sensorless, you have to have a more sophisticated computer, so the brushless DC motor can start. The problem is how to start this brushless DC motor. You do not know the position of this rotor, you cannot start it. So with the sensor, the electronics know the position, so it will drive just perfect. It will always pull the rotor in one direction. So this is another demo. I have a ton of demos. So if you need to do a project, generally all those motors cannot connect to a computer directly. So if this is your computer, that's one of my computer. This computer has a Wi-Fi antenna. So this is called Internet of Things. Internet of Things. And so if you have a computer, And you want to drive a motor, chances are you have to add something in the middle. See? So this will be the something in between your computer. This is called electronic drive. So I have two examples. I have actually three examples of electronic drive. So this is the three electronic drive. Let me go through each separately. So I have three electronic drive. The first one is an electronic drive only for servos. So only for servos. So basically, this electronic drive can control. Did you see the black, red, and white? So you follow that angle. So black goes to black. So if you see my black wire goes to black. So you plug in this direction. So this will drive one servo. If you noticed, they have another 7, another 8. So this drive can drive 16 servos. So one side is connected to a computer. So this is a computer connection, as I said. So my computer will connect to here. What computer? Any computer. A computer like this. A computer like this. By the way, this is my favorite computer. If you didn't know already, favorite computer. I teach computers, so I have a lot of computers. So the computer I teach are all look like this. This is the type of computer. This is called the embedded computer. The embedded computer is everywhere. So if you have a car, under the hood, you have 20 at least. You have more computer under the hood of your car than the Apollo station send the astronaut all the way to moon. That's how crazy today's computers are. They are everywhere. So this embedded computer will connect to here, and control 16 of those. So that's one example. This is the second example. That's another drive. So computer will connect to here. If you look at the connection, it's identical to the previous case. So that's what we prefer. We want to have standards. So that's the connection for the computer. Embedded computer connect to here. And this will be the motor connection. So this control a DC motor. This will be power supplies. So this one can control a motor as big as 100 watts. So because we are controlling a big computer, that's why we have a heatsink. And not only we have a heatsink, this is actually came off here. So they used to be together. So this is what the complete drive looks like. So I actually took it apart because I'm not using that. But if you're driven a big motor, you need this cooling the heatsink. So this circuit will not burn itself while trying to control the RPM forward and backward of a 100 watts motor. So a 100 watts motor will be most likely good enough, for example, for the dishwashers, for the food processors, maybe. So that's another motor drive. Then came to my favorite motor drive. This is my favorite motor drive. Why is my favorite? Number one, if you know me, it's cheap, inexpensive, right? I don't have money. So this thing costs about $10, $15, I don't know. So very inexpensive. Second, it's extremely versatile. Oh my, some of the stuff actually get loose. I have to read. So it's extremely versatile. extremely versatile. So what this does is okay, right here, extremely versatile. What it does is connect to this is a motor drive, and on the back of the motor drive is a computer. So I have a computer connected to a motor drive, and the connection is a standard connection. Just plug in on top of the computer. This computer is called Arduino. If you can read that, Arduino. Arduino is an alternative to this computer. So those are the two most common computers. This one is my favorite. This is Arduino, also favorite. What's the difference? The difference is this one is open platform, Arduino. This one is proprietary. So that's the difference. Proprietary and open platform. $50. I bought this $25, but now if you want to buy one of those, it's $50, $20, or $10. So Arduino, this computer, you cannot see the computer because it's underneath, in between, right there, is an open platform. This Arduino is maybe $20 because it has extra components. And this motor drive is like $10, $20. So in this motor drive, it has 4 motor drives. 1, 2, 3, 4. So 4 motor drives. And also they have 2 servo drives. So if you look at here, you have 2 servo drives. So 1, 2. So you have 2 motor drive, 4 motor drive, 2 servo drive. So what I'm going to do is give you guys a demo. I will plug in my servo. So that's my servo. I will plug in the servo. So servo is plugged in. So now I have a servo. I will connect a stepper motor. That's a stepper motor. The stepper motor needs two drives. So this is a stepper motor. I need 2 drives. So the stepper motor has 4 connections. The 4 connections goes to these 2 drives. And then on the right, I will have this motor, DC motor. So I will connect, I will unplug my LED and plug in my DC motor to the electronic drive. So that's it. That's all the motors. So I have 3 motors. 3 motors. A stepper motor, a DC motor, servo. And I will control the RPM forward and backward. I control the direction. I will control the RPM for each motor from my computer. So you need to download the program, just like the computer I'm using, the Arduinos. You need to download Arduino program. I already downloaded, so all I need is a power. So let me get the power. This will be the power. I need to go to plug in the power supply. So this is the power supply. I will plug-in. It's underneath the table. So now all motors are moving. All motors are moving. So if I have a speaker, so I put a sticker right here, so I tell you the RP forward and backward action of this stepper. And then I have this it's so now I have this DC motor. So the reason, so this is my favorite. That means I highly recommend if you need a motor drive, pick one of those. First, it's inexpensive. Second, it's very easy to program because it's Arduino based. Arduino is extremely popular among hobbyists. The learning curve are relatively easy, so you can start programming and having fun. And it can control multiple motors at the same time. So this is called Arduino motor drive. This is Arduino motor drive. There is a second version of Arduino motor drive. The second version of Arduino motor drive is a stackable. Stackable means you can put multiple Arduino motor drives on top of each other. So you can have a stackable drive. With the stackable drive, every drive, so if you put 10 together, you can control 10 times the amount of motor. So you can control, for example, 40 of those because you have 10 motor drive stacked together. So it's a stackable. So that's the second version. The second version, I think, I haven't checked the price. I would imagine the second version will be $20. The first version like this will be like $10. So if you're building a robot, building some kind of, for example, this is a stepper motor. If you have two of those, control horizontal X and Y's, you can build a router. You connect a router. Then you can build a CNC machine, not CNC, two-dimensional woodworking machine. And plus a third angle, this will be the up and down. So you have another motor lifting the wood cutting drill up and down. And you have two of these control the X and Y. I see people claim they make $1,000 every month just with this thing, just with this machine, carving wood, three-dimensional wood carving. So this will be X dimension. Another one will be Y dimension. The third one will be Z dimension. Goes up and down. All right, that's all the demos I prepared for today. It's all about motors. Motor is one of my favorite subjects. It's really old topic first. All those motors are invented or made 200 or 100 years ago. So they are an old topic, but it's also a new topic. Why? Because of this. The modern electronic drive make the old motor even more powerful, even more applications. And another reason this is my favorite topic is all the people know motors are retired. The younger generation only know this, or even don't even know. The electronics graduates only know this. It's hard to find the people understand both sides. That is the motor side and electronic side. So that for me, I think is a very good career direction. Electric cars, renewable energy. Renewable energy means this motor will generate electricity. So renewable energy. So you can put a motor like this and generate electricity. So it's a good, very high demanding area. And our traditional EE graduate, electrical engineering graduates, a lot of the programs do not provide those education. So that's where I felt it's a good career opportunity. All right, any comments, guys, before we turn off the recording? And
I don't know. It was a good demo.
Good demo? Thank you.
Yeah.
I have a lot of toys. Yes. Yes, Craig.
Well, I had just a quick question about the project that we're going to do with the lamp. So okay. I purchased the controller.
Perfect.
Controller. And I have a power source.
Okay, very good, excellent.
But how do I hook up the light to it?
Right now, just have the parts. I will have a more detailed instructions. I will have demo like this, how to connect each part. So right now, you just got the parts and hold on to the parts.
Okay.
I will have more instructions. So we have 5 more weeks. I may have 1 or 2 extra demos. Other than that, all those 5 weeks are concentrated on this PID controller project. So you have a ton of opportunities. I will work with you guys. Also, I will record it. Some people do not take this class real time. So with the recording, I hope I have just answer everybody's question for this PID project. It will be a good project. So is that good, Craig?
Yeah, that's good.
Yeah, I have started the next week or the week after. We will spend all the time lab hours with this PID controller. And that's an interesting controller because it's also the controller you purchased have self-tuning. I found the self-tuning works very well also. So actually that computer is smart enough. It can tune the controller automatically by itself. All right. Anybody else? See, we have Austin, we have Jeremy, we have Cameron, we have Tim. Got questions? Who else? That's all the person I saw. Let me see. I have a hard time using this Zoom. All right, if there are no questions, I will just close this.
I have a question.
Okay.
I just ordered the stuff, but the PID controller is telling me it's not going to be here until maybe not until December.
Where did you order that? Amazon?
Amazon, yeah.
Oh, why is not December? So
I don't know. It's got a pretty big range from November 9th until December 3rd, but pretty much
okay.
I miss the whole month of October if I don't get it.
Yeah. That will be a little bit of problem. You will, if you need to get that at least end of this month. Yeah?
Right.
Well, the only thing we do Amazon. My wife do Amazon is a seller also. Generally, you can contact the seller. Contact them if they should be able to. If it's inside United States, there's no reason you don't get it 2 or 3 days after you ordered it.
That because the seller is the ink bird and it's coming from China.
Why do you order? Did you order from a different seller?
No, it's from the ink bird. The one.
No, you order it from an Amazon seller, not Inkbird. Like the Amazon. Yeah, that will be a problem because it's maybe too late. I have let me check Amazon. Should have other sellers sell the same product instead of get it from China. You may not get it in this December. I have to tell you, if right now with this trade war and pandemic,
Right.
you may get it. You may not even get it in December. Yeah.
It wouldn't even matter though, because I wouldn't even be able to do the project for the class because the semester would be over.
Yeah. Make sure you. Try to get from a different seller. If you can cancel that order from China, that'd be good. I'm Google searching right now, so because some other already got their PID controller, like Craig already got his. I know others already got theirs. So when you place the order, make sure you pay attention to the shipping time.
Well, we'll see. I'll wait a few days and see what happens.
Yeah. You see, it's it says arrive November 9th. Oh, okay, November 9th. It has a fast delivery, October 23rd. In stock. Exactly, in stock. I would not worry. If it's in stock, just contact the seller. They should have that. So contact the seller. The seller is what is the seller? Yes, just contact them. Amazon has a very good. Amazon treat the customers very good. They treat the sellers terrible. So they just bully every seller. Just make you guys happy.
Yeah, I'll have to contact them.
Yeah, contact them.
Like they have other ones on here that can get here sooner, but they're not the same ones.
Oh yes. That's what I'm looking. Yeah, RLs are not as popular as the other ones. But I will. We will use RL because the safety reason. Everybody is working. Some of you have a lot of experience. Some of you do not. So I will just. All right, Tim. Hope that helps.
Yeah. I'll figure it out.
Okay.